Hi everyone, let's discuss QOD 7. If 3 times cos to 5 minus cos to theta equals to 1 minus cos to 5 cos to theta, then tan theta equals to k times tan phi, where theta and phi belongs to 0 to pi by 2, where k equals to. Now I get so many thoughts after looking at these equations. Maybe I can do cos c minus cos d, or I can do reverse transformation of cos to phi and cos to theta. I can do this as well. Maybe I can use double angle formulas cos to theta equals to 2 cos square theta minus 1. But I get no idea of what to do after doing that. But one thing which I can observe is I can see tan theta and tan phi over here. So this gives me an idea that what if I convert this into half angle formulas, basically converting cos to theta into 1 minus tan square theta upon 1 plus tan square theta. So that gives me an idea, okay, looking at this equation that I have to convert, I might convert this into tan square form, half angle formula in terms of tan theta. Now let's do that. We have equation as 3 times cos to phi minus cos to theta equals to 1 minus cos to theta dot cos to phi. Now what I'll do, I'll convert into half angle formula. 3 times. So I'll write tan theta as T1 and tan phi as T2 to make equation as simpler. So this will be 1 minus T2 square on 1 plus T2 square minus 1 minus T1 square on 1 plus T1 square equals to 1 minus T1 square upon 1 plus T1 square, sorry, T1 square dot 1 minus T2 square upon 1 plus T2 square. All right. Now what we'll do, we'll cross multiply it. 3 times we get 1 minus T1 square multiplied by 1 plus T2 square. Sorry, this is T2 square. This is T1 square minus 1 minus T1 square dot 1 plus T2 square. This is equals to, again we'll have to do cross multiplication over here. 1 plus T1 square dot 1 plus T2 square minus 1 minus T1 square dot 1 minus T2 square. Basically the denominator got cancelled from here and here. When we took the LCM, this denominator got cancelled. Now let's try to solve this one. Now I can see that 1 dot 1 over here and subtraction of 1 dot 1 over here. So that will get cancelled. Similarly, T1 square dot T2 square with a minus sign, and here as well T1 square dot T2 square with a minus sign. That will also get cancelled. So we'll be remaining with 2 times T1 square minus T2 square equals to, over here is 1 plus T1 square plus T2 square plus T1 square T2 square minus 1 minus T1 square minus T2 square plus T1 square T2 square. I can see that 1 gets cancelled, T1 square T2 square gets cancelled. Now what we are left is 6 times T1 square minus T2 square equals to T1 square plus T2 square 2 times, because this minus goes over here and it becomes positive. Now what we'll get, 3 T1 square minus 3 T2 square equals to T1 square plus T2 square. So basically 2 T1 square equals to 4 T2 square. T1 square equals to 2 T2 square. Now tan theta equals to T1 and tan phi equals to T2, right? Now in the given equation, we have to write tan theta in terms of tan phi, right? So here we got tan theta equals to 2 times root 2 times tan phi. So A is the correct answer. You can back check the calculation, but you got the approach. Let me summarize it once again. The main idea was dependent on tan theta equals to k tan phi. Having tan over here and cos 2 phi and 2 theta over here, that gave me an idea that we have to convert it into half angle formula in terms of tan theta or tan phi.